Oakley dokley, number 43. So in the circuit shown, both capacitors are initially charged to 45 volts. How long after closing the switch S will the potential across each capacitor be reduced to 10 volts? And what will be the current at that time? So through an RC circuit, Q equals CV, just for a capacitor, right? But our Q decays like Q naught e to the minus t over RC when you fully charge it up and then you just let it go. So here, we're going to want to combine our resistors and we're going to want to combine our capacitors. So resistors in series, we add them together. Capacitors in parallel, we add them together. So the equivalent circuit looks like so. We have our switch. We have one resistor with 50 plus 30 ohms, so 80 ohms. We have one capacitor with 15 plus 20, so 35 microfarads. Okay? So now from Q equals CV, and we know how Q decays with time, we can make the reasonable assumption that because V equals Q over C, V is also going to decay like V naught E to the minus T over RC. Okay? So we start with our original Q over C, so Q naught over C, and then it decays. So all we're doing is plugging this into there. Okay. So that's how we're going to get our voltage. And then our current, we're going to look at our resistor. So from V equals IR, our current is equal to V over R, which is going to be V naught over R e to the minus T over RC. Okay. So the current that this guy feels is going to be the same as the current that this guy feels. And because these things are in parallel, when this switch is closed, they're going to have the same voltage. All right? Okay. So using this here, we can solve for the time when the potential across each capacitor is 10 volts. So V is equal to V naught e to the minus T over RC. So V over V naught equals e to the minus T over RC. We're going to take the natural log of both sides to get rid of this exponential. So natural log of V over V naught is equal to minus T over RC. So T equals minus RC log V over V naught. Okay? So we can plug in our numbers. R is going to be our equivalent resistance. So our 80 ohms. C is going to be our equivalent capacitance, so 35 microfarads. Log, our initial voltage was 45. Wow, okay. Our initial voltage was 45, so that's V naught, and the voltage that we're looking at is 10 volts. So that goes up there with V. Okay, so if we plug that into our calculator, we get 4,210 microseconds. or 4.21 milliseconds. So now to get our current, all we have to do is take that current beautiful equation here. So current equals V over R. So V naught e to the minus t over RC was our 10 volts. Over R was our 80 ohms, which is our 0.125 amps. So we already took into account all of the time dependence when we were getting our 10 volts. So we can just do V over R here.